So on the back side here it says, solve each equation, show all your work, use any method, factoring, quadratic formula, completing the square, find the x values. Okay? So you're basically finding the zeros. Answers can be real or complex numbers. So I don't care how you solve these, okay? Whether you're doing quadratic formula, complete the square, okay? Factoring, whatever works for you, okay? So like when I look at the first one here, I can see factors of 13 that add up to 6 doesn't exist. So some of you might go, all right, I'm going to do quadratic formula right away. All right, let's do quadratic formula. A equals 1, B equals 6, C equals 13. So let's plug it into the quadratic formula. X equals the opposite of B, plus or minus the square root of B squared, so 6 squared minus 4 times 1 times 13, all over 2 times 1. So now as I continue to simplify this, I have negative 6 plus or minus, well, 6 squared, I'm going to change colors for a second here. 6 squared is 36, minus 4 times 1 times 3. I'm subtracting, I believe, what is that? 52? 36 minus 52 is negative 16, all over 2. Ooh, negative. Well, that's negative 6 plus or minus. Square root of negative 16, well, square root of 16 is 4. Square root of negative is I, all over 2. Again, square root of 16 is 4. Square root of negative 1 is the I. Now, this one I can reduce because 2 goes into both, so I get negative 3 plus or minus 2i. All right, second one. I did this one quadratic formula. Let's see, could you factor this one? You got a 3 out in front here. Are there factors of 3 times 12 or 36 that add up to negative 13? Sure. Negative 9 and negative 4. So I could rewrite this as 3x squared minus 9x minus 4x plus 12 equals 0. Now if you couldn't do that part, quadratic formula, it's going to be bigger, but you'll still get the same answer. So now let's see here, I can factor out a 3 and an x out of these first two terms. I'm left with x minus 3. I can factor out a negative 4 here. I have x minus 3. It equals 0. Now again, notice how the parentheses are the same, x minus 3. So I have 3x minus 4 sets of x minus 3. Now it's in factored form, so now we can use the zero product property, ZPP, you know me. So I set them each equal to 0 and solve. So this one I'm adding 4, 3x equals 4, divide by 3, x equals 4/3. This one I'm adding 3, x equals 3. And I got both solutions. All right, C, I see a quantity squared, and I'm already thinking, boy, could I get rid of that by doing the square root? I could if that negative 21 wasn't there. So I'm going to basically reverse PEMDAS this one. So x minus 4 quantity squared now equals 25. So reverse PEMDAS, take care of all your addition and subtraction first. That's what I did. I don't have any multiplication, so now I can deal with the exponent. So square root, my apologies, this 24 should have been a 25. So now I have x minus 4 equals, don't forget it's plus or minus square root of 25 is 5. Now I can just add 4 to both sides, so I get x equals 4 plus or minus 5. So 4 plus 5 is 9, 4 minus 5 is negative 1. Again, once you have these answers, you could actually plug them back in and see if they actually work. Okay? So again, you're going to have problems just like these. Remember how we said you had 4 of these that you could solve, any method. Okay? Trust me, it's easier to solve one method versus the other, but you can do most of them by doing the quadratic formula. Quadratic formula, quadratic formula. You could do this one quadratic formula, but you'd have to get everything to the other side. Make sure it equals 0. All right, next one. Convert each polynomial into vertex form by completing the square. Again, vertex form, y equals a, x minus h quantity squared plus k. So, on the first one, remember, vertex form, we're not actually solving for x, we're just getting it to look like this form. So move the 31 to the other side. So negative 31 plus y equals x squared plus 12x. Now, how does the process of completing the square work? Again, we're going to make this a quantity squared. To make it a quantity squared, you always take half of the x term, which is 6, square it, which is 36. Well, if I add 36 here, got to balance the equation, and add 36 to the other side. So when I do that, 36 minus 31 is 5. So I have 5 plus y now equals, how does this whole thing factor? We did this because factors of 36 that add up to 12 are x plus 6 quantity squared. Now you can see that you actually have right here the first part of your vertex form. All I have to do now is subtract the 5, y equals x plus 6 quantity squared minus 5. Look at that, it's in vertex form. Here's your h, which is negative 6. Your k is negative 5. Okay? And yes, it is a negative 6 because it's the opposite. All right. Letter B is the trickier one of the two because you got that number 2. But that first step, same thing. Move that 29 to the other side. So negative 29 equals 2x squared plus 16x. But I have a 2 in front of the x squared, so I have to factor that 2 out. But when I factor it out of the x squared, I have to factor it out of the 16 also. So reducing the 16 by 2 makes it an 8. Now I can complete the square. Half of 8 is 4. 4 squared is 16. This is the tricky part. The number I put over here is not 16. It's actually 32 because I added 2 sets of 16. The 2 times 16 is what I genuinely added to that side of the equation. So now I get 32 minus 29 is 3. I apologize, I forgot the y here. So it should be 3 plus y equals. Now, how does this factor? 2 stays outside here. Well, factors of 16 that add up to 8. That's why I wrote the 4 there. X plus 4 quantity squared. Move the 3 to the other side, so subtract 3. And I got my equation, y equals 2 times quantity x plus 4 quantity squared minus 3. All right, last two. Divide the following using synthetic division, find all 3 zeros. So synthetic division, the number we put up here, again, we take the opposite. It also happens to be one of my zeros. So right now I know one of my answers is negative 2. So to help myself find the other one, I need to do the synthetic division. So to get these numbers, it's just the numbers in front of each term. So there's a 1 in front of the x squared, a 7, a 16, and a 12. So how synthetic division works is you drop the 1, multiply the 1 to the negative 2, write it in the next column. Add the 2 together and repeat the process. 5 times negative 2 is 10. Add the 2 together, repeat the process. You do until the end, and hopefully you get a remainder of 0, which we do. So what does these numbers represent? That represents what's left. Well, this is my x squared, this is my x, so I actually have 5x, and this is my constant. So now I have this x squared plus 5x plus 6 equals 0. So now I just need to figure out the rest of the zeros. So let's factor. Factors of 6 that add up to 5 are 3 and 2. Then I can use ZPP. Yeah, you know me. Set them each equal to 0 and solve. So what you'll see on this one here is that negative 2 repeats. So you have negative 2, negative 3, and then I suppose if you wrote negative 2 twice, that's fine. okay? But really you only have 2 zeros on this one, even though it said find all three, one repeated. That can happen from time to time. All right, the last one, long division. So on this one here, it's doing this kind of the same thing as synthetic, but instead of multiplying and adding, we're multiplying and subtracting. So we ask ourselves, what would I multiply x by to get x cubed? Well, I'd have to multiply it by x squared. So now I distribute. X times x squared is x cubed. X squared times minus 3 is minus 3x squared. Now remember, the operation is subtraction. So 3 minus negative 3 is actually 6x squared. Bring down the 2x, and we do it again. We ask ourselves, what times x gives me 6x squared? Well, that happens to be 6x. So I get 6x squared. 6x times minus 3 is minus 18x. Again, I'm subtracting. That's 0. Negative 2 minus negative 18. Ooh, that becomes actually a positive, so it's 16x. Bring down the minus 48. Do it one more time. Whoops, 3. What am I thinking? I'm thinking the end result. What times x is 16? Or sorry, 16x? Which it would be 16, sorry. What times x is 16x? And that would be 16. So I get 16x. 16 times negative 3 is minus 48. So now if I subtract them, that's 0. Negative 48 minus 48 is also 0. So now I know that x minus 3 is a 0, and this x squared plus 6x plus 16 is a 0. So this tells me that x equals 3. But this one, I got to take a little bit further. Factors of 16 that add up to 6. I know some of you are going to go 8 and minus 2, but that multiplies to negative 16, not factors. So I have to solve it either quadratic formula or complete the square. Watch this move. I'm going to do complete the square, just to be different. Move the 16 over. X squared plus 6x equals negative 16. Now let's complete the square. Half of 6 is 3. 3 squared is 9. If I add 9 to one side, got to add 9 to the other. So what happens is, this factors to x plus 3 quantity squared. Negative 16 and negative 9 is negative 7. So I'm now going to square root both sides. So I have x plus 3 equals plus or minus the square root of negative 7. Well, square root of negative 7 is like saying I square root 7. So I can pull out the negative. But now I'm going to subtract 3. So it puts the minus 3 in front. There's my two solutions. Negative 3 plus and minus I square root 7. Alright, hopefully this key helped a little bit. I would study and review and practice these problems. Make sure that you know how to approach and do all these problems so that you can improve upon on your retake. Good luck. We'll see you again.